I should be recording. Not much of an opening, that is. But it's what it is. So anyway, yes, another draft physics or draft science video presentation. So again, the Sean Carroll. This was a nicely titled series. You know, it promised a lot, the biggest ideas in the universe, and so far you can't do anything with these. The ideas he say are the biggest ideas are, in my opinion, the most abstract and the least likely to be consistently true. You could argue that maybe some of what he says is correct about some elements of these things, but they're obviously, we're in this conflict thing between relativity and quantum mechanics. And there's a whole group of physicists who do understand that probably relativity is going to have to die. The notion of bent space doing it, it just isn't going to work on the small universe, and they sort of understand that there's only one universe, you know, and it's the small one. That's the one that's making everything. Everything emerges out of that universe, and so relativity is going to eventually have to go because it's completely incompatible. Space doesn't move anything. Okay, it's the things in the space that are moving things, and so you know, I can state that, you know, and say, okay, there, I'm in that group then, in the sense that I don't think between the two theories that this argument that somehow the space is local, that there's some sort of thing called a place in space that's a frame, or that somehow is separate, or somehow the rules are altered for perception purposes. Somehow instantaneous events aren't truly instantaneous because if I perceive them differently, that is, I'm closer to one than I am the other, that somehow I've changed the fact that they're instantaneous events. Those are kind of arguments that are just so fundamentally nonsensical and can't possibly be true kind of argument, that how you perceive an event has nothing to do with the event. There's a brick wall between me and something else and I can't see it. It doesn't mean something isn't happening on the other side of the brick wall. That the rules of the universe are the same everywhere, blah, 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 blah. Well, anyway, I can't frame myself into a different reality. That's one way of saying it. You know, you hate to rely on some sort of argument from intuition or argument from common sense, or but it's just like sort of examining a religion where they invent a character like the Holy Ghost, and you're saying, well, what's his role to play? How did he, you know, it's just this whole complex thing that you're saying, why do you need this Holy Ghost person? What's his function? The, you know, God's lawyer? What does he do? You know, it really does get convoluted and impossible to imagine that, oh yes, that's really how the story goes. That's even a fable. It's like giving the three bears, right? Going back to the little three bear story, and then giving them iPhones or something. Yeah, You know, you're just what? You know, I'm supposed to fall for that? Oh, come on. I mean, the cigar and the hat and, you know, slippers, okay, but iPhone? Come on. You know, who installed? You know, where's he picking his signal up from? Anyway, so that's how I would view this. So this video it's just going to be absolute, nothing will be about anything real. It'll just be about mathematical relationships that are, in my opinion, obviously flawed in their construction, where they essentially find an excuse to say a horse is the same thing as a zebra and a zebra is the same thing as a giraffe. You know, because they have something in common, hooves, you know, and that's all they're going by. And it's just nonsensical to say these are same things, like momentum is the same thing as. No, that's why we gave it a word, momentum. It's because it's a certain specific thing, and you don't say it's the same as. There's no same as. It's a specific thing, okay? Mass and velocity. And you don't pretend that you can mix it in some other formulation and say, I've preserved everything about it. You haven't preserved everything about it, but you're calling it something else, like the horse and the zebra. There's obvious differences, and they shouldn't be ignored, because in some positions, in some places, in some utility, it's round enough peg, it'll go in the round hole. Well, close enough. It's not a fair way to think. Okay, so anyway, so this part, he's on the rational board, just explaining dimensions. So, you got one dimension, a line, and then you can, if you're on that line, you can say there's a concept of perpendicular. That is, there's 180 degrees, and then there's 90 degrees. And if I were to draw another line 90 degrees, I've created another dimension. And the fact is, on the line, I can draw a line 90 degrees in two directions. There's, that are both perpendicular to each other. So frankly, from a straight line, I can imagine the other two dimensions by just making a simple rule. What's perpendicular? And I've already created the other dimension. So the rule, essentially, of three dimensions, the universe, is just that that's the only thing you can do with lines. That's the only way three lines can ever be perpendicular to each other, and that's it. You can't draw a fourth line. There's no fourth line that's perpendicular to all three of the other lines. So the rule ends there. And in spite of saying that overtly, he talks about other dimensions, as if they could possibly be real when they can't be imagined. They can't be drawn. They can't be in any way mechanically understood as being possible. There's no place for them to exist. The three dimensions are all there's room for. And that's it. You can't draw another line that's perpendicular to the other three lines. It's just a fact. And yet they keep talking about this other dimension as if it's just as real as the first dimension, the second dimension, and the third dimension, when it can't possibly exist by the standard, by the rule that a dimension is defined by a perpendicular line. So the conversation about dimensions should be over, and we should call them something else. Space has three dimensions. Physical reality has three dimensions, and that's it. The other stuff is functions in those dimensions. The other stuff is stuff can move in the three-dimensional space. And all they want to do is say the space is contracting and expanding, and that it's contracting and expanding in some local area, like a wind or something, and that's making things move. So they're making space the force carrier, if you want to call it that. They're making it elemental, and then they're making the elements move. So they're just believing in an ether. They believe space is a substance, and the substance has local character. And the local character defines how many notches you put on it, how tall the line can be, or how short the line is, how many notches are on the line. It's just defining for you how much distance or how much time will be consumed. So they've turned distance and time into dimensions. Obviously, distance would be, but time isn't a dimension. Time is a function, because it takes a certain amount of time for things to go from one place to another, for a force to be interacted with. All the forces move at the same slowish speed, the speed of light. Very fast speed, but very slow speed when you think of the distances that exist in the three dimensions. So it just goes all wrong. They go from the coherent and the real to the abstract, and they start saying this is physical reality. These abstractions, these holy ghosts, are somehow real players when they're just placeholders for the real player. The real player is a real force. The real player isn't something bending, a straight line bending. The dimensions don't bend. Stuff in the dimensions pushes on things, bangs into them. The wind blows and it blows things over. All right. But the wind is made of real stuff, real little atoms. There's no wind in space. Okay, there's forces in space. Substance that moves. from one place to another. And when it does that, it takes other things with it. All right, so we'll play some of this just to point out where perfectly rational, then he just loops into loop-de-doo.
Now, in space, if I'm not just on the iPad, but if I'm living in the room here, there's another direction I can draw, which we typically draw in pictures as sort of at an angle, but of course it's a cheat a little bit, okay? It's not truly on the board, it's not perpendicular, but we are imagining that we're here in space where I could hold up a stick in one dimension, hold up another stick perpendicular to it, and hold up a third stick perpendicular to both of those. So voila, space in which we live is three-dimensional.
Right, and it makes sense, right? Because you can make a box out of that. If you just put flat planes on the end of the lines, you can understand it just becomes a cube. And if I do it a little more complicated and draw lines from the endpoints to all the other endpoints, I'll end up with a diamond, an 8-sided cube, cubic. So that fits with all this basic solid geometry. And they're breaking that fundamental geometry by saying somehow that we can distort any old place in this in this cube for reasons, who knows, Holy Ghost.
Try as you will in the space in which we live, you cannot take 4 sticks, hold them up in a way that each one of them is perpendicular to all the other 3. So space is not 4-dimensional, it's 3.
Right, so there we go. Space is not 4-dimensional, it's 3-dimensional, but I'm going to add a bunch of other dimensions. They're not dimensions then, right? I mean, this is a specific thing. A specific rule defines the creation of the dimension. You have to be perpendicular to everything else that exists. You're done now. There isn't anything else perpendicular to everything that exists, so you're done. That's it. That's the end of dimensions. Like again, you want to create some other thing, then understand what the other thing is. And I would argue that we know what the other thing is. We know that the function is movement, and that movement happens at a certain rate. That the force moves really fast, and that the matter moves really slow. Okay, so obviously the force has to work to push things. And the pushing is in the form of acquisition. So this sort of gets to something I guess that might be a useful conversation about how we think about how momentum happens in the universe. And so I've sort of drawn this stuff before, but I've been over it and over it. I mean, you can think of 2 things hitting. The thing is that they could go right through each other. That could be the way it functions. Could be that they bounce off of each other. One goes this way and one goes that way, right? And it could be that they miss each other. One goes this way and one goes that way. They're all the same outputs. You can't see any difference in the universe, so the movement doesn't create anything. If this was the simple rule. Now all I have to do to screw that up, to make that a different world, completely different, is I just have to make a difference. I just have to create a force that, say, has a color. Okay, we'll just say that's the rule. And now all of a sudden it's very different, because if the two things miss each other, then this is going this way. If it reflects, then the green's going this way, right? So you can get the idea. And if they miss each other, the green goes this way, right? So now there's not the same output. Now they're not all equal, right? The output is going to be different, and that's the universe that we have. So I'm arguing from my own perspective that this is a better way to think about momentum in the universe. In the first place, is to think what makes the difference, what makes things change. And you can't make change with just one object missing or hitting or doing anything. You can only do it if the objects are fundamentally different and then have fundamentally different process. So the green is different. It's going to affect protons and electrons inversely and differently, and therefore the universe will change fundamentally based on what hits each other. It's going to matter now. The universe won't look the same when it misses and when it hits. So that's one simple principle I don't think he's ever thought about. I'm just saying, because it's fundamental to understanding this acquisition. So here's the other part of the question. You can have the idea of something hitting something, a piece of energy, and its movement, its momentum, okay, you say dies. So this momentum gets transferred to this object, and this object moves. So this momentum merely moves into this object. So this thing stops moving. It doesn't, no more movement. So I don't know how to exactly just draw that, but this one stops, this one goes. That's traditional. The way we think about things is that's the rule. And if you suppose that something does both things, which is kind of strange, that it goes in and it reflects, well, we say that for it to reflect, this thing has to give it energy. Can't get it for free. So you can't, in theory, move this and move that way. That's not conservational. All right, so that won't work in this system. So you can't have a reflection, because that's essentially saying you've got two momentums now. You've created the momentum this way, and you've created a momentum this way. And the argument is you can't do that. Well, the trick would be is that you really didn't do that. You did two processes that were distinctly different. So the idea would be is that this arrow in here could be going this way, or it could be going this way. All right, when you show up. And so if you show up and you hit it when it's going this way, you can understand how, well, that can be a pure reflection, in the sense you get something going this way and you got something going this way. But if it hits it while this is going that way, that is, it adds, okay, to this. So it was coming, it was on its way, and as this bounced back and forth, you could sort of understand that each time it's going this way, this one catches up on it, right? So each time it goes this way, this object gets closer, 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 and closer. And so the idea would be that when it's finally here, if they're both going the same way, then it ends up being two forces going this way, right? So now you've added the momentum this way. You've given this object 2 arrows worth of momentum this way instead of just one. Anyway, the point is that you can understand it as a more than one step process. So it's essentially the same as what I've argued is, the idea is that there's energy in the matter already, and that all you do when you have an interaction is you replace the energy from the external world and you release a piece of energy in this world in the opposite direction. And so you've not only changed inside here, because before you had this and this, and now you've given this back, so you've gotten rid of that by giving it back to the universe, and you've added another one of these. So you've changed something that was this and this into something that's this, and you've got this too. Now it's all conservational, you didn't cheat anywhere, you didn't create any extra momentum, you've conserved the energy, but you've done this thing that you're not supposed to be able to do, which is reflect, okay, not kill your energy, and you've added energy. You've added energy this way, you've added energy in this way, but you did it obeying the rules. So I'm just saying there's all kinds of ways to look at how momentum is exchanged in the universe fundamentally, and I would argue that they haven't really thought about any of that, and all they're saying is, first off, they're just saying everything's the same thing. An electron is the same as an atom, is the same as a molecule, is the same as a horse. Okay, I mean, they're just saying, we're not gonna recognize that these are all different things. Okay, that this isn't the same as this, isn't the same as this, isn't the same as this. That the universe is this. Okay, electrons and protons, and that's the fundamental charge elements, and that they move, and when they move, the atom moves. When the atom moves, the horse moves. That can be understood. So the real universe is happening here. All right, it's not happening here. It's happening here. Electrons and protons have to move in space for anything that we call a thing to move. That's what it requires. And that the forces are all just some sort of photonic pressure, just like photons, same kind of energy at a stream, a ray, you know, this idea of turning everything into waves is just wholly ghosty. You don't need to have waves of energy. You just need to have momentum. Momentum, 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 momentum. Little bits of momentum moving through space is what causes electrons and protons to change their position in space. They go to a new place in the 3 dimensions, and that's everything. That's why things move in the universe. It's not because space, okay, is framed and these things are in frames and that you can warp the lines in the frame, okay, and cause the frame warpage to move things, and that the frame warpage happens at the speed of light. I mean, it's just totally way superfluous. It's a totally unnecessary complexification that doesn't need to exist. And I guess you could make comparisons to evolution theory, you know, where they first thought that, you know, well, they speculated about our will, and that, you know, our will was being transferred to the next generation. If I had if I had some sort of brilliant idea, you know, I thought of the light bulb, you know, that somehow my kids would already have light bulb thoughts in their head, you know, somehow what I wanted or what I hoped for or what I wished for, like somehow my wishes would be extended to the next generation. I mean, it was unnecessary complexification of something that was a simple rule, is that if I managed to survive to be old enough to screw enough chicks, that I would have prodigy, and that my prodigy would have the same skills I had, as physical skills, and that they were likely to do the same, you know, be just as capable as me of also having kids and having kids and having kids. And that's all you need to eventually create the giraffe's longer neck, is I'm going to be more successful if I've already got one, you know, that I physically acquired, not that I wished for. Alright, some context. So we'll play a little more, then we'll just jump through it and I'll just demonstrate how it's all this. He starts going into Hamiltonians, you know, replacing the concept of, you know, velocity and position with some sort of just momentum and direction. You know, all things you don't need to do. You don't need to transfer these things. You don't need to turn energy into frequency, for example. It's not a pure thing. It's not, like I said, a Volkswagen going down the street. Do you really think it has a frequency? That in some way or another it's turning on and off? That it's disappearing and reappearing in the universe or something? That it jumps? You know, whatever.
Three-dimensional. That's it. That's why space is three-dimensional. That's why we know space is three-dimensional. But why is space three-dimensional? I mean, why is it like that? Why are there...
Well, why bother with that question, right? I mean, it's, you know, it sort of makes sense. It makes nice geometry. It makes circles. It makes lots of things. So, in a sense, 3 dimensions makes sense that there would be 3 dimensions, because lines, the simplest thing you can think of, 2 points in space and the shortest distance between it, you can understand that I can form those 3 lines into that configuration, and it obeys these perpendicular rules. And so why should I question why it exists that way? What else could it be? I guess would be the question to ask, right? And what he's suggesting is it could be Holy Ghost. It could be some abstraction. Well, why would it be an abstraction? That's a complexification. Why make it more complicated than it needs to be? 3 dimensions creates a whole bunch of space and creates a whole bunch of room for things to interact in that space. So why would I question the existence of 3 dimensions? That would be like questioning the existence of the 2 dimensions, if they existed and there was no third. Would I say, why isn't there a third? No, I'd say, okay, that this doesn't exist. It didn't happen. Space didn't make it. The universe didn't poof that way. It's not what it's made of. It's made of 3 dimensions. Just happens to be made of those 3. I don't know. I mean, these kind of questions, you know, origin questions of where was the first something, you know, I've said it before. you're only going to hurt yourself. You're not going to get anywhere. And what do you think? You think there's actually some explanation? You think some other being had to create it that way? I mean, what? Something intelligent had to figure out 3 dimensions, perpendicular straight lines? Like you needed a high intelligence to figure that out or something? No. There's no reason to believe why there's a universe that the answer is going to be fulfilling. Like you're going to say, oh, that's such a great explanation. It's just going to be some mechanical explanation. It's going to be robot speak. It's not going to be some poetic, beautiful thing.
3 dimensions rather than some other number. So if we were being historically accurate and sort of...
Well, we know why there's only 3. Because it's really hard to find perpendiculars when you've already used up all your angles. So you used up all the angles. There's no more angles to use up. So yeah, you're all out of perpendicular. That's why there's only 3. It's because you used up all the angles.
What did we talk about last time? Like force and action and things like that? We're still kind of stuck in the 18th.
Yeah, force and action and things like that. That's right. The other videos, I couldn't even make a reply to them because they made no sense at all. These force and action. I don't know. But he didn't talk about anything that actually forces anything to do anything. So the forces aren't real. The forces are all abstractions.
Hundreds at best. There's not that much you could have said about why space was 3-dimensional. Well, what else could it have been? Maybe you could have said, but there were no dynamics. There was no way of saying, well, had it been something else, it would have evolved into 3 dimensions or anything like that. These days...
So again, I would argue, though, if it was 1 dimension, perpendicular would be something you could understand. You could say, what's perpendicular to this line? And you could say, well, this and this. So you could do it.
We know a little bit more, right? And we're skipping ahead historically to point out that when Einstein does come along, and in 1915 he invents the general theory of relativity,
he should say he discovered. So I'm glad he said he invented, because like a religion, he just invented it. Okay, I don't think he discovered the truth. He just invented a convoluted way of looking at reality and pretending it works that way, because the rules are so ambiguous and amorphous. I mean, they're intangibles, non-falsifiable, that you can't do anything. You can't argue against it because it presumes nothing that is tangible to us from this perspective. We can't move the speed of light, therefore we can't see if those rules apply.
He says that space is part of space-time, which is 4-dimensional, not just 3-dimensional.
So again, how does it do that? How do you create this extra dimension when you've just pointed out the rule for dimension creating, and now you're going to say somehow I can break the rule for free? That's no problem. I'll just pretend the rule doesn't exist. And I'll say the word 4th dimension even though it can't possibly be related to those first 3 in any way as a dimension. Now, it can be a function. Time is a function. Time can move you through that space. Okay, you can move along those lines if you have the time to do it, and it will take time. But again, that gets back to the argument that what's moving on those lines ultimately moves because there is a force in the universe moving the speed of light that forces things to move. Nothing moves for no reason. Nothing moves because the dimensions change. They move because a force moving in the space interacts with it. That's the simple answer. That's the evolution answer.
But he also says that it has a life of its own, that space can change, that there's a geometry.
So, yes, and it changes based on rules that would be consistent as if they were real things moving, like the atmosphere and the wind blowing. Now, some primitive could think the atmosphere goes forever. He wouldn't know. There's a limit to how much of it there is. And he could say, yes, this atmosphere blows me places, right? This stuff, this space around me blows me. Okay, but yeah, we already know better. We know that those are real atoms that are banging into you. You don't move because the wind blew you. You move because the wind represents a bunch of mass that's moving, that carries momentum, and that momentum will be transferred to you. It's a transfer of momentum through the space. The space itself is not blowing. The space is not stretching. The space is not wind. You can't make wind out of space. You have to make wind out of substance, because only substance can carry momentum.
Geometry to space that need not be the geometry of Euclid, where initially parallel lines stay.
Right, so he says, he just said it. You need not. We can make space into wind, okay, by giving it density all by itself. We'll make it into particles of air molecules, and then we'll move the air molecules as if they were driven by forces. I don't even know how they're doing that. It's an ether theory. Their theory is an ether theory. They think space is a something. They don't think space is nothing and that the somethings move around in it. That's not what they're thinking. They're thinking the space is the something, and you could even call the things that are moving in it nothings, because they're different than the stuff that's moving, the space. So now everything's space moving rather than the stuff in the space moving.
Parallel forever. Space can be warped, and it can change and be curved in various ways, and you and I experience the curvature of space-time as gravity.
Right, so again, he's stating it as a fact. There's just nothing to prove this fact. All they've demonstrated the existence of is that there's a correlation between velocity and clocks breaking, which sort of seems obvious. You can break clocks really easy. Trust me, as a kid, I was a great clock breaker. It was so easy just to push it right off the shelf and look at the guts and say, how the hell does that thing know how to tell time? See, as a kid, I was curious. So I wanted to know how the clock knew what time it was. So I engineered little accidents so I could see what was in the clock, because I wanted to know how it knew what time it was. Anyway, I didn't know what time it was. Anyway, I'm saying, how does that dumb fucking piece of wood know what time it is? I mean, it annoyed me. Anyway, but there was an answer, a mechanical answer. And there's a mechanical answer to why atomic nuclei decay at a different rate when they have velocity. Lots of mechanical explanations are possible. I've given a few of them. That decay is a real thing that happens. It's environmental exposure. And you can be, there can be one tiny drop too much acid rain that falls on a statue and then its arm falls off. It's just a fact that, yes, everything's exposed to the environment, and if you're exposed in a certain way, that is, something can go in this side and this side at the same time and hit the middle at exactly the same time. Now, it doesn't happen too often, but it can happen. But when you move, you make it happen less often. That's the simple answer. So yes, atomic nuclei decay slower when moving. That doesn't prove the existence of a time dimension. That doesn't prove there's any such thing as a frame that you're floating through. So anyway, there's nothing about relativity that is especially proven, that there's volumes and volumes of evidence, and the rest of it has to do with bending light, and all of those experiments are flawed. So Einstein never was proven right. He never deserved the New York Times headline, Einstein right, all of that kind of crap, because at best, tiny elements of the theory were demonstrated to be possible. And at worst, it's not even close to a proof for the whole elaborate theory. Any connection between space and time as a dimension, that you could move forward or back in it, that has any of those possibilities exist. All right. Again, because Feynman could create mathematics where particles could move around in time, that a particle coming out today could have affected a particle existing yesterday, its position yesterday. Because math can do that, there's no reason to think physical reality can do anything like that. Anyway, I mean, this gets into a whole conversation about what is math anyway. And clearly the word formula gives you some indication of what it is. And what's a formula? It's a formalization. So you're just taking elements, variables that are relevant, and manipulating the variables, which is a perfectly rational thing to do. But it's not a model. And it's not going to obey rules automatically. You have to know the rules. Okay? Because it doesn't know the rules. It knows 2 plus 2 can be 4, but it doesn't know 2 plus 2 can't be something else until you make a rule that says, no, it can't be anything else. It can just be 4. Well, if you don't know that rule, you're going to be in big trouble, because 2 plus 2 is going to be 8 and 17 and all kinds of, you could draw any kind of squiggle on the other side of the equal sign, say it equals that. You have to know the rules of two-ness and the fact that 4-ness was invented to explain two-nesses. You know. It's like understanding the definition of words. I mean, it all goes back to some origin where you're basically saying this equals that. But anyway.
And almost as soon as Einstein came up with this idea, people said, well, that's interesting. That means that I can change the dimensionality of space. And so let me just explain a little bit about...
Right, so that's all they're really talking about, is I can make it bigger, I can make it smaller, and then I can bend it. And instead of having real forces in the universe, I'll just bend space where I need to bend space. So again, this is just an example that Sean Carroll seems really invested in the relativity side of quantum mechanics and not so much quantum mechanics, in the sense that that's why I guess many worlds appeals to him, because many worlds just undoes the fact that there are rules for events, because now everything that was possible, okay, did happen instead of only one thing happening. So he doesn't have to force everything to fit into one universe and explain why it did this time, when he can just say, oh, it did everything, so it doesn't matter, which is just so nonsensical. Well, anyway, this will not be the future of physics. Quantum mechanics is its future, not relativity. And if they have any hope, eventually they'll figure out that quantum mechanics is just a placeholder for the real mechanics, which is forces are real things, and they carry momentum, and they exchange it by rules that are a little different than the rules they're thinking it runs on.
What that means. Imagine that you had two-dimensional universe, okay, two-dimensional space. So just because it's easier to draw, not because it's actually conceptually more important. That would be better if I could draw more dimensions. But imagine that space was two-dimensional, but imagine that it was wrapped up into a cylinder rather than being an infinitely big plane.
Right, so there's just no point, right? I've added some other mechanism. I've taken a dimension and turned it, and so it's not straight line geometry anymore. I'm just going to pretend things are curved when there's no reason to believe anything's curved. There's no evidence of this curvature. There's every evidence that things travel in straight lines, and straight lines are quite durable, and the speed of light sort of indicates it. Obviously the curved line would be a much longer way to get from here to point A to point B, taking the curved line. It's not what the universe is doing, because it would have to change the speed of things. Things would have to go faster than the speed of light to go these curved lines. So they really aren't a player in the real universe. So again, this is just an abstraction. Alright, so he does this, all this curve crap, and then he creates cylinders, and then he pretends, he can make them different sizes, and if I make them different sizes, you'll perceive them entirely differently, and, so this is just stretching and warping and saying that the 3 dimensions are doing, every time something moves, it's because the dimensional space around you is somehow contracting and expanding in different directions. So they're artificially creating movement in the universe by artificially creating fat and thin space or something, instead of dealing with it by what we know is there is a force that moves the speed of light, just like a photon. So again, I can keep looking at the light and saying, you've got to be able to understand that the light is doing something here, right? That it's sending rays of light, that it's radiating a force, and that the force takes time to get from one point to my nose or whatever. It takes time for it to do that, for it to go from there, to fly off of there, and end up here. So,
It's a two-dimensional surface that you can go around in one of two different directions.
so this was really disappointing because when he starts getting on this string gas cosmology thing, so it's an element of string theory, he starts talking about toroids, and you're just, oh please don't do that. It's this silly Ken Wheeler bullshit. He says, well, it's a square toroid, for the sake of his drawing. But it's just so disappointing. Yeah, oh please. The universe is a toroid. Oh please. Just too silly.
But another way of drawing this torus, which I just drew, would be to draw a
Torus.
square, but identify the opposite sides. So the point of this picture is to say, if I were a little person,
Right, so if I was a little person here, we live in a magical universe where you walk one end off the one end of the earth and you automatically pop onto the other side of the earth. Why would I think the universe works that way? That things just poof from here and they just poof over here. Why would I think it works that way? It doesn't work that way. There's no evidence it works that way. There's no reason to create these special functions. There's no excuse for creating them. All right, we'll go a little ahead. But this has nothing to do with space. You got to understand, this is not a conversation about anything called space.
2 points. On a line, 2 points will always hit each other. In two-dimensional space, they will generically move by. Likewise, strings generically move by each other if space is four-dimensional, but not if it is three-dimensional.
Right, so this idea, so this fourth dimensional space is impossible. He pointed that out. It breaks the rules, so there is no such thing. So of course, if you're going to add a dimension that can't possibly be perpendicular to any of the previous lines you drew, then the fourth dimension can't have any contact with the other three dimensions. It can't possibly be relevant to the three dimensions because it's not perpendicular to them. It's not obeying the rules. So the fourth dimension is nothing. It can't be rationally connected to the other three dimensions. So why are we having a conversation about it? Why do you think it's the source of understanding? And so you have to wonder, well, why does their string theory need 11 dimensions or 9? Whatever the number is. They use different numbers. Why does it need 9 dimensions to work? And exactly how does it work? Will you show me some place where it explains why a magnet's a magnet, or why charges are positive and negative? Will you explain to me why they have this inverse relationship with this theory? No. I haven't seen anybody point out why the mechanical universe looks the way it does through string theory. It's a mathematical formulation where they just go x equals y. There, I've completed my job. My job is to prove that x is y, and now my theory works. Well, how does your theory explain a charge? Oh, it doesn't. So what good is it? Oh, that's right, it isn't of any use. It's useless garbage.
Initially tiny compact manifolds, and the tiny compact space doesn't have to be a torus. It can be something more complicated. So the initial charm of thinking that you have explained why space is three-dimensional.
So they call something. So they call something a brain. The shortcut for membrane. So this is like their up quark, stupid quark, retarded quark, specially enabled quark. All their little silly words and games they play. Just demonstrating that physics is really juvenile. This is just a bunch of little kids, adults who never grew up, who are just trying to make everything into something super cool. They're trying to make transformers. They don't like boring Legos. They want transformer Legos. They want super guns and super fun stuff, and it just has nothing to do with trying to be grounded in explaining what is a pretty simple phenomenon. The basic function of the universe seems really simple: pushing and pulling. And then the argument is, well, yeah, all the pulls can sort of be understood as inverted pushes. So yeah, it's just pushing. What do I need all this crap for? To explain that thing A hits thing B is affected by getting hit. There, can't that just finish it?
Down a little bit when we appreciate more of the complexity of string theory. But still, again, it's an attempt, right? Maybe something like this is actually explaining why.
Well, yeah, so he doesn't even believe, these are theories he's talking about, he doesn't even go for them necessarily, but he's throwing them into this conversation of space, as if this is somehow relevant, when, why would it be relevant? How is this defining the simple concept that there's 3 physical dimensions? now let's talk about the functions that take place in those dimensions. But there's no point in saying the functions are dimensions, because they're not. Moving on a straight line is not the same as having a straight line. It's not a dimension of straight lineness. It's just, well, anyway, there's no point, I guess.
And this goes infinitely far down.
Right, so here he creates the infinite gravity well. I can bend space any way I want to. There's no rules. So again, they don't know the rules, so they have mathematics that can do things that the physical universe isn't going to allow you to do. We know there's no infinite force in the universe, just as there's no infinite wind blowing on the surface of the earth. It's not an infinite source of wind on the surface of the earth. We know that the wind has to be made of these physical elements, and you can only have so much density, and you can't make the water and the oxygen and the nitrogen. You can't make the molecules into lead, so you're certainly limited in how much momentum you can ever create. There can only be a hurricane of a certain size, and you can't get any more momentum into it. You can have a maximum amount of momentum in a amount of space, and that's it. But all their math says we can do this infinite thing. We can just keep creating little infinite spots of the universe, and it's just so unbounded by any kind of reasonable rule. Why would you think the universe creates infinite amounts of anything, whether it's bending or whether it's photons or whether it's anything? Why do you think there's an infinite supply of any of it?
So in some region, if you just stretch space, you kind of imagine pulling it, and you pull it infinitely far, but it doesn't keep getting smaller and smaller as you pull. Rather, it stabilizes at some fixed size. If you imagine...
So by whatever rule that would be, right? So does that make any sense? I infinitely pull, but at some point I'm not pulling anymore. The pulling doesn't have any effect. It just stabilizes into some sort of stable pull. What does that even mean? How can that even make sense? So it obeys certain rules as I'm pulling it, and all of a sudden the rules stop. So when I hit a certain point, I can still go infinitely more, but it's all the same. If I go two infinities, it won't be any different than one infinity. So they already have an equation for that, right? They have an equation that says 2 infinity equals 1 infinity. Because they can't get around it. It's just, 3 infinity, that's the same as 1 infinity too.
Just looking at, I'm actually going to invoke a suggestion that was made in the questions to other videos, which is, rather than me pointing at my pad, that you folks can...
Okay, well, whatever. He's just giving production lessons.
I shouldn't call these lectures. Casual chats about the biggest ideas in the universe.
Hey, casual. What's casual about this? It's so loop-de-doo and out there. Toroids are casual? Well, the universe is a toroid. That's not like some kind of extraordinary claim. Space is toroidal. I think it's an extraordinary claim, and you should at least have some reason for why I should waste my brain space, my neurons, sitting there trying to imagine the universe as a fucking toroid. Why should I bother with any of that crap when I know the light isn't toroiding to me? The photons from that frickin' light bulb are not going any fucking toroid.
But we can have fun. We're not teaching you a course. There's no quiz at the end of this. So why is it actually 3 dimensions?
Maybe we can have fun. I don't know. So this is their definition of fun. Let's create all kinds of convoluted, bizarre... Well, maybe the 3 bears have springs on their shoes. Yeah. Does it mean anything? No. Is it somehow important to the story? No. Is it relevant somehow? No. It would just be cool.
I have no idea. There was an interesting paper by Max Tegmark. Max, of course, is a well-known cosmologist and writer.
Another one of my friends who does all this little wacky bullshitting. Another bullshitter.
The guest on my podcast, Mindscape, a few months ago, when we talked about the anthropic principle and the multiverse and other ideas he's a big fan of.
Yes, garbage.
And so there was a paper where he applied these ideas to the dimensionality of space. And what he claimed, which I think is a little bit of an overclaim, but I can explain why, what he claimed is that there is an anthropic reason why, even if you had many different parts of reality where the dimensionality of space was different, we would find ourselves in the 3-dimensional part. So
So the dimensionality was different. So again, he established the rules for what a dimension is, and just now talks about, well, screw the rules. We'll just the dimensionality's different. Let's put those springy things on the bear's feet. It's cool. Let's give Goldilocks 3 eyes, right? I mean, they're just making this shit up. Can we maintain the integrity of the story by just making up a bunch of superfluous crap?
Planets gently perturb you out of your orbit, right? It's not just you and the sun moving around in the solar system. We also have Jupiter and Mars and Venus.
Right, so he has another argument against the existence of higher dimensions, because higher dimensions would mean that orbiting wouldn't be possible, because the higher dimensions would be constantly irritating the orbits in ways that would destroy the capacity of it to compensate for the momentum changes. It can't. An ellipse wouldn't be possible because you're not processing it in an angle, you're processing it in a direction, and that's not going to work. You're going to destroy the inverse square law. See, even that, when they describe the inverse square law, he does it in this video, I think, somewhere, but I probably aren't going to be able to find that spot. I mean, to me, the way to describe it is to do the obvious understanding that if lines are diverging in 2 directions, that is, there's 2 dimensions, right? This dimension and this dimension. So I have lines that are diverging in both of those directions. That creates a square, okay, in space. So the point is the square gets, goes, when I go half the distance, okay, the square is 4 times bigger here. So there's 4 times more area. I have to spread the same number of little bits. So I have certain little number of bits that go through this square, and that same number of bits has to go through this square. So obviously those bits will be much more separated in space. So if I'm out here, I'm much less likely to encounter one of these bits in this big square than I'm likely to encounter them in this little square. And yes, those look like rectangles, but who cares? Now that's a rational way to understand the inverse square law, that the light is spreading in 2 dimensions. Okay, it's not a 1-dimensional thing, it's a 4-dimensional thing. The object is spreading this way. The stuff is getting less dense. It's the bullets. I'm shooting bullets. I'm shooting them not only moving this way, I'm also moving the bullets this way. And you can understand that that's going to make it a lot harder for a bullet to hit this target. If I could only jitter this way, you can understand I have some chance of hitting the center. But if I'm also at the same time jittering this way, then I have, 4 times less chance of hitting the center. All right. And so their explanation is, what was it? I can't remember it now offhand. But anyway, this is the inverse square law. You don't need anything more. This is why there's an inverse square law, is because we know the light is point source. We know it's shooting out in rays, just like charge. There's lines of force. And we know the lines of force are diverging from each other in 2 dimensions. They're going this way. They're moving away from each other this way and this way with distance. No other explanation required. Let's see if it gets the...
and all those other things. So it is only in three-dimensional space that planetary orbits are stable. So what about dimensions greater than 3? These orbits would be unstable. What does that mean? It means that, you have some position, you have some velocity or some momentum, okay? What if you so you're going around in some orbit, what if you just tweak it a little bit? What if you have some force, like another planet, that moves you away from your orbit? What would happen in dimensions larger than 3 is that rather than just being in a slightly different orbit, you would either spiral into the center or escape to infinity. Those are the generic things that could happen. That's what it means for the orbits to be unstable. You could move in a perfect circle, but if your circle is not perfect in 4 or 5 or 6 dimensions of space, then you could not orbit forever and ever.
So that he even has a condition on it, right? So it's only because that most orbits are ellipses. Now, there's no rule that says they have to be ellipses. It just happens that to create an orbit, a viable orbit, the object has to come out or has to come into the system. And in doing that, in going out, the idea is it already has escape velocity, and somehow you have to slow it down so it doesn't escape. So everything that stays in an orbit because it interacted with something that slowed it down. If it comes from the external universe, it has too much speed, and the point is it'll either crash right into the sun, or it'll spiral out of the universe. It'll bend out of the universe. And unless it hits something to slow it down, there's no chance of staying in an orbit. So orbits are always created by an interaction. You have to have an interaction to have an orbit. That's the real rule. The ellipse is just a consequence that the object had to come into the orbit, or it had to be slowed down to stay in an orbit. And by being slowed down, it's going to create the ellipse. It's going to have it. You're going to change your speed, and by changing your speed, you're going to be either forward or behind, a little bit, the object. And so you can't be in a perfectly circular orbit. You could be. It's just highly unlikely to get exactly the perfect speed change to put you in a circular orbit. It's just the odds are way against it.
So maybe we think that for intelligent life to arise, you need something like planets moving around stars in long-lived orbits. Again, I don't know that you really need that. I'm pretty much wholly unconvinced by this. The two-dimensional space...
Oh, whatever. So he's talking about making beings in two-dimensional space, like this is somehow a meaningful conversation in terms of what a being would have to be, in terms of what complexity would be. How many interacting bits you could put in a space is really what complexity is. But anyway... So yeah, the more space you have, the more place you have for more bits to be complexly related, kind of obviously. So I thought the inverse square law part was here, but I guess...
Particle or some object with a position and a momentum, and then you chug forward in time and ask what it does. Then we said that there is the least action way, which was you take it in...
The straight line. So again, this is just so... it's just so... Let's just forget that straight lines are probably what the whole thing is made out of. So again, they're assuming a geometry where, a curved line is elemental. And so I sort of went through this before, with this simple kind of spirographed argument you can make. I could take a string between 2 points, and we could say that the string is elastic. So I can bend the string, or the string is relaxed. There's more string than I need. And so I take the string and I put a pin in it and I move it until it's straight. Well, what I can do is I can have those string taut. So there's straight lines that define the position here. And as I move the position, these two straight lines will create a curved line. So as I move the position, I'll travel this curved line. But we know this curved line is made out of two straight line elements of tension. The tension is the straight lines. So the curve is an illusion. The elemental universe doesn't bother with curves, that it probably is a bunch of straight line geometry, that the elements of the universe might be just squares or cubes or whatever, but that's the more elemental object. And all this talk about curving stuff, there's no natural curve. Nothing travels a curved line. Nothing on its own just says, I'm going to curve. Anything that curves is being forced to curve. Okay, it just doesn't do it because it likes to be curvy.
Initial position, and you take a final position, both with some fixed times, and you find a path in between them that minimizes a certain thing called the action. So it's a more global versus local point of view. You might think that those two options are all you get, but
So again, this action crap just has to do with this. Going sideways doesn't matter. What's the real thing that they're defining is how much energy does it take to get from point A to point B, and what force is raining this way. Going sideways is just wasting time. It's like climbing a hill. Walking sideways, technically you're not doing any work because you're not going up the stairs. You're not going up anything. And so in the end, the only thing that's really relevant is how much of that space did you occupy or consume.
Another way, called the Hamiltonian point of view. So this is a way of formulating classical mechanics. It's not a different theory. It's yet another reformulation of exactly the same theory. It seems at first glance like a needless bit of formalism, okay? Like you're taking something...
Yes, the whole thing seems like a bunch of mush. Okay, so the Hamiltonian, again, just forget that things have mass and they have velocity and that those two things make momentum, and instead we'll just say momentum exists from, magic. It's just like pretending the light bulb isn't the source of the light. Right? And so I could just make an argument, well, if I know how many photons are here and here and here and here and here and here, and all these places in space, if I can know all of that, I don't need the light bulb anymore. But wouldn't it be easier just to recognize the light bulb is causing it, and I know how the light bulb creates a bunch of straight lines, and so why don't I just draw the light bulb? Why would I just draw the force when I know what the force is caused by? See, this just breaks the cause and effect chains. That's all they're really after in this mush, I think.
And velocity. Position and momentum. Sorry, position and momentum. That's the whole point, is that it's not a function of position and velocity, it's a function of position and momentum. So, we said that the energy equals, sorry for the math here, but I think the concepts are easy enough to follow. Energy is kinetic plus potential.
Right, which are two fake concepts. Okay, there's no such thing as anything having potential energy. It can only have energy because, like in gravity, because you're in a position and you're going to be hit by a force. You don't have any potential energy from gravity. Gravity doesn't give you any energy. It creates an environment around you that is going to oblige you to move. It's going to force you to move. So again, see the disconnect. They're saying I don't have to bother with what's causing the effect. I can just say this is an affected object. It possesses potential energy. And well, how do I know it possesses potential energy? Well, it's not because I looked inside of it. No, that's not where the potential energy is. It's because I looked at the field around it. Well, duh. Of course. The stuff is going to affect it. The force is going to be applied to it, and it's going to move it, okay? But there's no such thing as it possesses it. It never possesses it.
And we had little formulas. Kinetic energy is 1/2 mass times velocity squared. Potential energy is just some function v of x. It only depends on x, not on the velocity or the momentum. So if velocity is momentum divided by mass, then this equals 1/2 p squared divided by m. Right? If you plug in v equals p over v. And
right. So they're just, again, doing this exchange stuff. Because in one circumstance, this is true. They'll assume that, number one, that it's true in all circumstances. And it's all the same thing, which it's not. So how is this there to say that? To understand the danger of doing this. But this is how they changed momentum, P, into F. Basically said momentum is frequency, when it's not. It is only in the case of photons.
Potential is still just v of x. So in other words, this energy, this is now the Hamiltonian. It is a function of x and p. It equals 1/2 p squared over m plus v of x. See, there's no velocities that appear in there anymore, just momentum p and position x. Okay.
Right.
Again,
and there's no velocities when, of course, you can't have momentum without having a source of it. So what's the point of saying there's no velocity in there? When you can't know momentum without knowing mass and velocity. It's impossible to derive it any other way. You can't find it any other way. So anyway, so all this Hamiltonian crap, curved lines, bent space, blah, blah, blah. So real forces don't move things. They're moved because the space bent. And so it's just a bent space theory of space. It's just no...
P and x on kind of an equal footing, right? They treat them almost symmetrically. There's little details here, but basically, rather than p being derived from the velocity and therefore from the position...
So you have x, y, and t. So you get the problem here, right? So there's only two physical dimensions and then something called a time dimension. Well, where's the other third dimension, the real dimension? Okay, so again, it's not... They're replacing an actual physical dimension in space with a function. That can't work.
It has a life of its own. It's a quantity all by itself. There's the location, there's the momentum. These two quantities go into defining the Hamiltonian, and from them we get the laws of physics.
Right. Well, duh. So, I mean, you could just understand that obviously if I know how fast, which way something's moving, how fast it's moving in that direction, and I know how massive it is, and I know where it is, well, yeah, I know just about everything I need to know about that thing in terms of its ability to hit me or its relevance to me. So how is this math helpful? You have to already know all of those facts to do this math, to resolve this math, but this math won't tell you the answer to those things. It won't tell you. If you know the outcome, yes, you can dissect the process by which you got to that outcome. We all know that already. We don't need this to do that. This is just another version that abstracts from reality. You could do it the old way and get the right answer. And you get the right answer for the right reasons. You don't need this.
Moving toward each other in good old Newtonian mechanics. Okay, so they have a position, x1, x2, and they have a momentum, p1, p2. And if they're billiard balls, so they don't have, forget about the gravitational force of them or anything like that, neither of these billiard balls will know about the existence of the other one or be affected by it until they hit each other, right? Until they smack into each other in the middle. In other words,
right, so he's discounting the existence of a force between them that could be bouncing back and forth. So this is my ping pong paddle argument that what's moving electrons from electrons is the fact that they're exchanging a force back and forth. And so the closer you bring them, the faster that force has interactions. The more interactions, the more energy is converted. And so you're just increasing the pressure. So I just bring the paddles closer together, lots of pressure. I bring them further apart, less pressure, kind of an obvious circumstance. So clearly the two objects are communicating with each other. We know the speed of the force. We know the communication is taking place. They're breaking all of that and saying space is doing it instead. So I have to contract and expand space to make the two things move towards each other. I have to make the space almost infinitely small in the sense that I force them to hit each other by contracting the space.
They do not interact until they are at the same point in space. There is no analogous question, no analogous statement about momentum. So if the two billiard balls have...
So this is such an irony because we know that information, like the two simultaneous explosions, we know that it takes the information about the explosion time to get to me. We know that that isn't when the event took place. So again, this is this is just such a perversion to say we don't already know there's a force moving the speed of light that carries information, and information is an interaction essentially. You don't gain information until something interacts with you, and we know the force is the carrier of the information, if you want to call it that.
Had the same momentum, or the opposite momentum, but were pointed in different directions, so they would never hit each other. They don't interact with each other. There's no sense in which having the same momentum or equal but opposite momenta has anything to do with whether you are interacting with each other.
Yes, right. Well, of course, obviously, because there's three dimensions. But if I contract that and say, well, they're on the same plane, so they will hit each other. I get there's just nothing here that is insightful, in my opinion. This is just convoluted, complex ways of explaining something very simple.
So the motto here is interactions. This is a simple example, but we can extend it and generalize it, are local in space. Real.
Right, so this is just kind of nonsense, right? I mean, there's no local space. There's just space. And the three dimensions are always the three dimensions, and light always takes the same amount of time to go anywhere. So this is just all rubbish. Well, whatever. Unproven, and it is intuitively stupid. So I think this might be where he talks about the inverse square law being this curved line. So yeah, this is that part. Okay. So this ought to be somewhat useful.
A negative number. So there you go. Here is the distance between, let's say, here's the sun, here's the Earth, and phi, it's on the vertical axis here, it looks like this. And he invented two equations. One equation was...
Right, so this is a drawing of what I did with the inverse square law. So this is one way to see it. It's one way to look at it on a chart. Okay, there's a lot of change. In the beginning, your line has a high slope, and then your line tapers off because the effect is getting, the weakness is getting, what's the right word for it? It's taking the long road to infinity. It'll never get straight with that line going this way. It'll just keep trying to get halfway closer and 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 halfway closer forever. So that line is, in a sense, an abstraction because it doesn't recognize what the cube thing does, right? The ray thing tells you quite clearly that for every object there is no infinity that's going to work, right? So if I have something that's radiating objects, there's a physical fact that places like here in the universe, no ray will ever hit that spot. So what we've done is made this some sort of probability equation or something and just saying, well, the average over all these spots will be one impact in a million. And so we're taking something that absolutely will not happen. This location, a photon will never from this object go to that location. Just a fact. One might hit here, one will hit here, but never will one hit here because this thing was only lasted for one pulse in time. It sent certain rays in certain directions, and none of those rays happen to be this spot in space. That spot in space will never see one. All right, so their line is an abstraction of a truth that there's only the fact is there's for each point in space this line won't be exactly the same. Some places in space will get this. Some places in space will get, this line. There'll be a bunch of different lines for each location in space, and all they're doing is saying what's the average. So they're averaging a reality. They're generalizing it, but it doesn't recognize the physical fact that there's a certain quantity of this, and when I spread that quantity over a surface, there's definitely going to be places where nothing will hit, and there's places where 10 things could hit. There won't be any averaging in the reality.
What does phi do? And the answer is when you have a big, massive object, phi pushes it down. Okay, that's why the sun is pushing down phi down here at r equals 0. The other equation says if you're a little object, even if you're a big object, if you're an object that is in the midst of some phi, if you're feeling the influence of some phi, there is a force on you that is just like the force we talked about for potential energy before. That's why it's called the gravitational potential field. The force is minus the slope of the potential.
Right. And again, I would argue that that's not the reality, because that line is assuming that you can generalize about every point in space, and the reality won't be a generalization. Just like when you flip the coin, there isn't any generality. Okay, there is a specific thing that you're going to do, and the specific event's going to take place, and it wasn't anything called probabilistic or any of that stuff. It was inevitable, and it the cause is the effect. So how else to say it? But anyway, I think you can get my point. That understanding that I'm taking a volume and saying there's a certain density of stuff here, and if I take the same amount of dye and I put it in a vessel that's 4 times the volume, that obviously the dye is going to be diluted and it's going to be a lot less capable of obstructing my vision. That's the better way to illustrate it than this silly curved line.
So Laplace invents a set of equations which says there is something in between the sun and the earth, and that something is the gravitational field, the gravitational potential field, and I can write down equations for it where there's no action at a distance at all, right?
Right. There's a cause to the effect. And because Newton played with this for a while, this Fadio idea that, yes, well, let's create a bunch of pressure in the universe, a bunch of ultra-mundane particles, and see what the consequences would be. And some of the consequences look like, well, that can't work because everything's going to be dragged to a halt. Well, again, what is everything in the universe, right? Everything isn't the same thing. An electron and a proton are not Oldsmobiles. They're not 747s. they obey rules that are different than the rules that 747s obey. Let's see what happens. Let's see if there's any way I can... The 747 isn't obeying. The rule it appears to obey isn't the rule that the atomic bits are obeying. They are functioning through drag. They are overcoming drag because they have the little parts to do it. They have the function of charge. The plane doesn't have that function, so we don't see it happening, but it's happening on its subatomic level. So I guess the real point is they're not getting, as much as they say they're doing particle physics and subatomic physics and all this stuff, they're not really getting to it. They're not getting a good description of the elemental functions. That's why they can't explain to you why there's charge, and they can't explain to you how a magnet makes things move without creating a force, without generating energy.
Where the force, the influence of the sun on the field only happens where the sun is located, then the field obeys its equation, which tells what is the field right there. It depends on what is the field right next to it on one side and what right next to it on the other side. And guess what? You use calculus to relate what the field is doing at one point to neighboring points. But that's all that affects it. All that the field at one point cares about is what the field is at immediately neighboring points.
So again, this is another thing where he's just taking away the light bulb and just saying, well, I'll just see how many photons are 1 inch away from me, and then I can know how many are going to hit me. Well, of course you can, but wouldn't it be easier just to say I know what the source is, and I can calculate how far away the source is, so why do I need to measure every single point in space 1 inch away from me when the simple thing to do is just recognize how many watts is coming out of the light bulb?
There's no influence very, very far away. So the action at a distance has gone away. It's field theory. This is the answer. Why is there no action at a distance? The answer is the world is made of fields.
All right, fields of what? Doing what? How do they do it? So again, there's no mechanism. There's just this ambiguous notion that a photon is a field, and the field has created a certain amount of momentum here. Okay, it'll push things here, but we know it's a source. We know it's a push. Anyway, so enough. So he goes into the next videos. We'll
So
make up all kinds of crap.
Another particle over here. Let me draw this particle better. Okay. So we don't know the spin.
We even said this wrong. I mean, little errors like that are okay. He's doing this stupid entanglement crap. So the spin here is up, and he should have said the spin here is down, right? Because the two are opposite, not the same. So he says, well, if we know the spin here is up, then we know this one's up. They're not up spins. They're up and down spins. Well,
Either one of these. This is usually in the trade Alice's particle and Bob's particle. So we know that both of these particles are spinning in the same way. In fact, even if you orient their spins to try to measure them in some other axis other than vertically, if you measure them horizontally or whatever, you always know they're spinning the same way. And what we don't know is what way that is. So when Alice measures her particle and she says, it's spinning up, then Alice instantly knows that Bob's particle is also spinning up. And if you believe that
so we know that Bob's particle is spinning down, so he didn't get that right. But anyway, see, this is the subject is space, and here he's talking about this dopey spin property, which they concede isn't even spin. But the funny thing is this just has to do with some scenario where you're gonna break a photon down. So you could take ultraviolet light, and you could understand that it has enough energy, in theory, to create 2 photons of infrared light. Okay, that you have enough bullets, and all you do is slow the bullets down. You could create 2 photons of infrared from a piece of ultraviolet. So they send a piece of ultraviolet light into this little crystal device, and what they're getting is 2 photons. Now you could understand that the way the photon is being made is you could almost argue that an electron does move from this position to this position. So it moves back and forth between these 2 positions. And what would that cause? You could sort of say, well, it would cause the universe, when it's in this position, it's bouncing energy this way, and when it's in this position, it bounces energy this way. But it can't be in both these positions at the same time. So obviously, when it's in this position, that's phase would be on, right? And then at T2, okay, at the next timing interval, when it's going to be in this position, you would have phase 2, right? The phase would be T2 phase. So when this one's on, that is when this one is pushing, this one isn't doing anything. When this one's pushing, this one isn't doing anything. So the two are just out of phase. So you have two photons, one going this way, one going this way, that are just exactly out of phase. So if I was to draw those two infrared photons, the argument would be, this is what they would look like, right? One of them, its node, okay, the wave bullshit would be exactly the opposite. So where this one is off, this one is on, and when this one's off, that one's on. And I would do it with these bits because that's actually the right answer. Okay, but you get the idea. So you've created two photons out of phase. That never changes. They're always out of phase. They're always opposite photons in that sense that they're out of phase. Now you can do, if you're arguing, I'm going to do the same things to them, put them through an obstacle course, and then the output, they're still going to be out of phase. Duh. Okay, unless you change the phase, they're going to remain out of phase. So they're right-handed and left-handed gloves right from the beginning. There is no entanglement. There is no one of them can be either right or left. No, its phase is its phase, and its phase is its phase, and those two phases are just opposite phases. And the experiment's all done with polarizing film, so this is just about phase. So there's no this photon doesn't know what phase it's in, and this photon doesn't know what phase it's in. They're not relevant to time. They're not both living in the same time dimension. Of course they are. Of course they're just two photons created oppositely. They're not the same photon. They didn't start off both in phase. They didn't start off, on T1 and then, or they didn't both pop out at T2. So they have a difference right from the beginning. Anyway, there's no point in getting into that. But I mean, to take space and then start talking about spin, I mean, it's such horseshit. Well, whatever. Just no. Like I say, I'm waiting to see if he ever gets to charge and magnetism, right? The two most intriguing, interesting force, and gravity, of course. But no. Instead, the biggest ideas are these mushy ideas that space isn't really space. It isn't really 3 dimensions. It isn't any. I mean, and this is there's this expectation by people that I should find this nonsense compelling. That some reason my brain should say, oh yes, the universe is wacky and silly and preposterous and nonsensical, when it can be understood simply, push, by a real thing, pushing, banging into, interacting with, by traveling a certain speed through space. It's very discouraging that all of this mush, these convoluted stories, actually make sense to somebody. Hard to imagine. I'm having a hard time imagining it. Like the fourth dimension. I'm really having a hard time imagining why you people gravitate to this loop-de-doo bullshit.